All right, we're back. We're on page 82 of the math analysis notes, and it's kind of like a summary page. I just want to make sure everybody really understands what it is that they're writing, because I know you can kind of get into this like auto mode where you're just like doing the thing you were told to do, and you never really think about what it is you're doing. So we're going to look at one problem kind of in detail, just to like make sure everybody is seeing what they need to see. So half of the solutions to our equation here, right? Having trouble getting a highlighter. Our equation is sine of x equals negative root 2 over 2. So like you can solve this by thinking about the unit circle, basically. So I am telling you right now that half of the solutions look like this. They look like 5 pi over 4 plus 2 pi m. But like, what does that really mean? So what is the 5 pi over 4 part? I'm going to say that that is, it's one of two angles between 0 and 2 pi such that the sine of x equals 5 pi equals negative root 2 over 2, right? So the sine of 5 pi over 4 equals negative root 2 over 2. So that's an angle between 0 and 2 pi. Now we have this plus 2 pi n part because any angle coterminal will also satisfy. So you got to really kind of think about these things, everyone. Sat is, I guess that's right. That looks like, it looks like it's missing a syllable. Satisfy. Okay, so any other angle that's coterminal, that's going to satisfy it. So we can actually write out a lot of those angles. So when you do that, I recommend, so we're saying x equals 5 pi over 4 plus 2 pi n, right? Where n is an element of the integers, obviously. Common denominators are like so much your friend. So instead, think of it as 5 pi over 4. This is like basically when you're trig graphing, you want to do this kind of thing. Let's make it 8 pi over 4 times n, right? And so now, if n is equal to 0, we get 5 pi over 4. If n is equal to 1, we get 13 pi over 4. Then we just keep adding 8, so 21 pi over 4, 29 pi over 4. So this was, let me say this is 0, 1, 2, 3. Got to add 2 more, add 8 2 more times. So 37 pi over 4. And then finally 45 pi over 4. So we're just adding 2 pi every time, but we did ourselves a favor, right? We decided that we were going to, so I'm going to say these are x equals, and then put it in brackets, because it's a list, right? It's a set of answers. We did ourselves a favor when we got that common denominator, so you definitely want to do that. So use your calculator to confirm your answers. Do in fact make sense. Okay, let's do that in exactly one shot. So go over the calculator and see if we can do it. I mean, we're going to be able to do it, I think. So let's just look at what it says on the paper. It says to type in sequence SEQ 5 pi over 4 plus 2 pi n times n. Use a pi key. If you don't use a pi key, you got to put multiplication, because do you see that? It changes it into pin. No, pi times n, where n is the variable. I'm going to go from 0 to 5. So this, you can just check the things that you wrote on paper. And that looks good. Now what we're claiming is that if we do sine of x such that x equals these, it should just spit out negative root 2 over 2 every single time. And it does, which is telling us that we got it right. So this is how that formula works. It's basically a function that generates solutions to a particular equation. So let's go back and see if we can do the rest of the page. I don't actually know what's on the rest of the page. Oh, there's a lot on the rest of the page. Okay. Well, not so much, because we did this. Let's put a check. Check. All right. So there are exactly two values between 0 and 2 pi such that sine of x equals negative root 2 over 2. This is why we memorize the unit circle, right? We know 5 pi over 4 works. We also know x equals 7 pi over 4. And then once we have 7 pi over 4, anything coterminal to that is going to work. So in general, we'll get 7 pi over 4 plus 2 pi n, where n is an element of the integers. All right, now we want to do the 0, 1, 2, 3, 4, 5 thing. So we really want to think of it as 7 pi over 4 plus 8 pi over 4 times n. So our solutions will be, so I'm going to do the set right from the beginning. All right, 0 gives me 7 pi over 4. 1, so I just got to keep adding 8, which like, I don't, it's not really my strong suit in life to just add over and over again. 0, 1, 2, 3, got to do 39, and then 47. Okay, so I get all of these, and then it wants us to use our calculator again. So let's go and do that. So here we go. All right, so I'm going to try to type in a thing that'll do it. So sine of x such that x equals, I'm going to combine the like sequence of 7 pi over 4 plus 2 pi times n, where n is the variable, and I want to go from 0 to 5. I should get, and I do get, negative root 2 over 2 every time. So you can like kind of tease this answer out of solve. So solve negative square root of 2 over 2 for x. So we get this. So for example, the second one I think is basically this, right? But I have to first add 2 pi to like convert to get the 7 pi over 4. So what I'm going to do is I'm going to say like x2, I guess, of n is equal to, pull this part, and then change this from this like bolded n to just like a normal n. And now I can do x2 of 0, x2 of 1, and I can just punch it in, and if I want to know when it's 5, I get this. So that's definitely a thing that you want to try to do. Just get amazing at using your calculator. I mean, every chance you get to try to extend how much you understand using the calculator, like go for it, because it's only going to pay off in the long run. There's never a reason to like sit there and be like, oh, I wish I hadn't learned that about using your calculator. Like, when's that going to happen? So it definitely worked. Here's a screenshot of me solving it. What do you think I'm doing? Oh, you actually watched me do it, right? So here, the thing that we were given, so maybe not there. This part, this is negative pi over 4, not 7 pi over 4, because for some reason, the calculator always goes with the negative. I don't really know why. I mean, it probably has something to do with arcsine, I guess. I wonder, I should look into that, if it has something to do with arcsine and arctangent, give you the negatives, and maybe inverse cosine doesn't. I don't really know. But I was just adding 2 pi to get like the next one so that I could do the exact formula that we used. But anyway, that explains a little more in depth what this is. I mean, you maybe already understood it. Hopefully you did. But if you didn't, hopefully you understand it better now. And really think about these things. Don't just try to mindlessly do things. That's not the way to be successful in general, but especially in this class. So I hope you found this helpful, and I will see you in the next video.